Hi folks, Mr. Long here. I'm doing a screencast for the composition of functions and limits, or sorry, composition of functions, not limits, differentiability and continuity. Those were the topics of the test, and I'm just going to do a quick screencast to go over the mastery questions so that if you made a mistake in one of the mastery questions, you can make sure you learn it. So here we go. Here's the first derivative. And this is what I call a simpler chain rule version. So 1 divided by the square root of 6x plus 5. So again, it's all about what do I notice when I first look at this? Well, the first thing I notice is I've got a square root. And immediately I see a square root, so I'm thinking exponent 1/2. I also see that it's in the denominator, which indicates division. Exponents that are negative indicate repeated division. So I'm going to rewrite this with rational exponents. So that slides down. We replace the square root in the denominator with negative 1/2. Okay, so that's the first thing that you're going to do. And now we can start to analyze and decompose this. Okay, so it's a chain rule question, which means I have an inside function and an outside function. So it looks to me like the inside function is 6x plus 5. I'm going to call that u. And the outside function we're going to deal with in a second. So the inside function, again, it's 6x plus 5. Then the derivative of that will be du by dx, and the derivative of that is just 6. Okay, and then we go to the outside function. What's our outside function going to be? Well, if I look at the outside, I've got brackets to the negative 1/2. And what I'm doing is I'm calling u 6x plus 5, so it's going to be u to the negative 1/2. Okay, that's the outside function. Now I need to differentiate that. So I need to subtract 1 from negative 1/2. Negative 1/2 minus 1 is negative 3/2. And I have to bring the negative 1/2 out in front. That's dy by du. And to simplify it a bit, so I've got the negative 1/2 there. Oh, whoops. I need to put something there. There's got to have a 2 right there. Sorry, folks. Got to have a 2 right there. So negative 1/2 2u to the 3 over 2, because a negative exponent indicates repeated division, so it becomes a positive exponent when I put it in its appropriate place, which is in the denominator. Okay, so now what we need to do is to combine those. So to make sure I've got it right, what I need to do is take a look at this. So I've got, what have I got? Du by dx, dy by du, so the du's cancel out. So if the du's cancel out, I end up with dy by dx. Okay, so I've done it right. I've definitely done it right. Okay, so now I need to just multiply. And what I'm doing is I'm going to multiply this right here and this right here. Okay, that's what I'm multiplying right there. Okay, the shaded parts or the highlighted parts. So again, I would do 6 multiplied by negative 1 is negative 6 divided by 2 is negative 3. And that's why I get the negative 3 there. The next thing I want to do is look at where I have variables. I've got u to the 3 over 2. So that's going to be exponent of 3, and then the 2 in the bottom here indicates square root. So, and then I replace u with 6x plus 5, and that's the final answer. Okay, the next one is what I call a 3-layer chain rule. And for the 3-layer chain rule, you can see that the most inside function I call u, x squared plus 7. Then we move out 1 layer, and I probably should have that continuing out to the v part should continue out to 1 plus. So I'll just add that there in black. I don't have a blue pen right here, so that goes out to there. And then the y is actually everything. Okay, so the u again is x squared plus 7. The v is 1 plus, and again, what denotes the end of it is a bracket, okay, or a square root symbol. So you can see very clearly the first one, the set of brackets at the here and here. Those are the first set of brackets. Why don't I just put there, and then that bracket. And then the next one would define the next set of brackets there and there. Okay, and that's going to be our V. So U is inside the yellow brackets, V is inside the bluish aquamarine brackets, and then Y is the whole thing. Okay, so all we have to do is write U, x squared plus 7. You know the drill for get the derivative of that. V is then the 1 plus 4, and then what is this? This thing here is U, 1 plus 4 U cubed. And we have that, then we get the derivative of dv by du, 12u squared. That makes sense because 4 times 3 is 12. The derivative of 1 is 0. Finally, I have everything inside, which I'm calling v, right? I've already done that here, call that v, and then I have v to that exponent of 5. Okay, so exponent 5. And then I do the derivative of v to the 5th, which is 5v to the 4th, and that's dy by dv. Now, I always want to check and see if I've done things right. So what I'm going to do is look at this. So I've got du by dx multiplied by dv by du. So it looks to me like the du's cancel out. And then I've got dv here and dv here. That divides out or cancels out by division. And what's left? dy by dx, which is what I wanted. So now what I do is I multiply everything out. So remember, what I'm multiplying is that, oops, this, and this. Those are the three things I'm multiplying together. So the first thing I would multiply together are the coefficients. 2 times 12 is 24, times 5 is 120. So check down here, 120. Then I look for, in order of complexity, from least complex to most complex. So that means I go from u over here to y, 2x, or the x part rather, because we've taken care of the 2. There's the x. Then I have u squared. So if I look at what u is worth, x squared plus 7. So I have x squared plus 7 squared. Finally, I have v to the 4th. Well, what's v? V is this whole thing right here. And so I can actually just take that and look at that. That's what v is, 1 plus 4 bracket x squared plus 7 cubed. And I have that, and then to the exponent of 4. And that's it. I'm done. Okay, so next one. This one is a little bit more complex. This is a quotient rule and chain rule combined. What's the first thing I notice here? Well, what I'm noticing is that I have a cube here and a cube here, which means I'm going to rewrite it. Because I have an exponent of 3 on the top, exponent 3 on the bottom, I can just replace that with a single exponent of 3. So I write the fraction there with a single exponent of 3 on it. Once I've done that, then it's going to be a lot simpler to work with. And it also really does look like a composition of functions now, because I have this 4x plus 1 divided by x plus 5 as the inside function, and the outside function is cubing. So if we're going to do the chain rule on this one, maybe I'll just bring something out here to work through it, so to follow along. So again, the key thing there that I noticed is that I had the cube there, and I can rewrite it this way, so I have a function very clearly inside another function. Now I could have done it with, I could have done the 4x plus 1 cubed with the chain rule, x plus 5 cubed with the chain rule, and then done the quotient rule. But my preference is just to do it once, so just to do the division once and then apply the chain rule. Okay, so it's very clear that the inside function is 4x plus 1 over x plus 5. The outside function then just becomes u cubed. Okay, so this means it's a quotient rule question. And the quotient rule, top prime bottom minus top bottom prime, all over the bottom squared. You're probably getting to the point where you might have that memorized. And what we do here is work through these. So now the way that we write it, I'm writing it as top prime bottom because it's top prime bottom in the formula. Same with this top bottom prime, so I write top bottom prime beside each other. So the top is 4x plus 1, which makes the derivative, top prime, 4. Okay, whoops, a daisy. Try that again. 4. And then the bottom prime, x plus 5, that's 1. So now what I need to do is to multiply those out. So I'm going to have top prime bottom, so it's going to be 4 multiplied by x plus 5, and I would expand that out. 4 times x is 4x, 4 times 5 is 20. And then in the bottom, I've got 4x plus 1 times 1, okay, but I'm going to be subtracting that. So let's take a look at what that looks like. So I did the 4x plus 20, which I expanded out nicely here, subtracting off 4x plus 1. So when I do this, I've got 4x subtract 4x. So that's canceling by subtraction. Those 4x's are gone. All I'm left with is 20 minus 1, which is 19. And then it's over the bottom squared. So that's 19, x plus 5 squared. That's the inside derivative. Next, we go over to here and dy by du. After doing that big chain rule question, I think it doesn't seem very difficult to do the derivative of y equals u cubed, which is 3u squared. Okay, so we come over to here, and now we need to put everything together in the chain rule. And if we're going to put everything together in the chain rule, I need to double check that I've done this right. And let's see, did I do it right? dy by du multiplied by dy by dx. So if I've done it, sorry, du by dx multiplied by dy by du. So I've got the du and the du, and those divide out, right? One's above the other in multiplication. And it looks like I get dy by dx, which I'm supposed to get. So now what I'm going to do is replace things as appropriate. So du by dx is this right here, 3u squared. Okay, and then multiplied by 19 over x plus 5 squared. Now, on your mastery test, if you just wrote this, you got full marks because I wasn't asking for full simplification. Now, if you want to simplify it more though, however, you can. And what you do is you're taking the 3 and you multiply by the 19, and that brings you 57. And then you have 4x plus 1 on the top squared, which gives you 4x plus 1 on the top squared. And then the bottom, notice this, I have x plus 5 squared here, and and that has an exponent of 2 on it. So x plus 5 with an exponent of 2 on it. But I also have x plus 5 with an exponent of 2 on it here. And if we multiply things with the same base, we add the exponents. 2 plus 2 is 4. So that's 4. Okay, so that is those are the questions that you need to do for derivative rules with the chain rule. Go over those very carefully, especially ones that you made mistakes on. Rewind, pause, practice a few more.